before we install ROS2, it's important to check which ROS2 distribution you need to use. And you can find the list of distributions on the website here, docs.ros.org, or just search for ROS2 distributions and you will easily find that page. So once you're here, you can see all available ROS2 distributions. In green, those who are currently supported, and in gray, those who are not supported anymore. And you can see that from now on, we will have one new distribution every year, which should be released on May 23rd. And it's quite easy to know what is the order here. It simply follows the alphabetical order. So you can see here A, B, C, D, E, F, G, H, etc., etc. And so we're going to check two things to choose which version we want to use. The first thing is the EOL date. EOL means end of life. So after this date, the distribution is not supported anymore. And so after the date, you should probably not use this, and it's best to upgrade to a new version. So you can see when the EOL date is passed, here it's in gray or white, and when the EOL date is still valid, it's in green here. And the second thing to check is that, well, is the version an LTS version or not? Okay, LTS means long-term support. And how to know which version is a long-term support? Well, it's quite simple here. Foxy is a long-term support version. Starts from 2020 to 2023, so we have 3 years. And then every 2 years, so 2022, we have ROS2 Humble. This is an LTS version also, okay? And any LTS version starting from Humble is going to be supported for 5 years. So the EOL date for Humble is going to be May 2027. Okay, that should be this or something very similar. Well, we are going to be able to switch to Humble without any problem. And well, before we continue, one last thing to pay attention to is, well, which operating system version you need for the ROS2 version you choose, because each ROS2 version is linked to specific versions of Ubuntu, for example. So if you click on Foxy Fitzroy, and well, we can go down and you can see supported platforms, okay? So we have Ubuntu, macOS, and Windows. You can see that for Ubuntu, the version is actually Ubuntu 20.04. So if you want to use a ROS2 Foxy, you need to use Ubuntu 20.04. Okay, and for example, the version ROS2 Humble, which is going to be released in 2022, is going to target Ubuntu 22.04 or something like that. So as you can see, if you change the version of ROS2, you also probably need to change your version of operating system. All right, and now that we know which version we're going to use, let's continue and let's install this.
Here you will install Ubuntu 20.04 if you don't already have it. Note that I will only use Ubuntu for this course. So I'm going to show you which tools and which IDE I use to program with ROS2 on Ubuntu. So I'm only making this video so you are not stuck when I use a tool that you don't know or don't understand. But anyway, you use any tool, any IDE you want, it will really not matter for this course and for your ROS2 experience. So first of all, I will of course use the terminal, the standard Ubuntu terminal, and I will also use the what's called Terminator. So Terminator is kind of an improved terminal where you can easily split the screen and have multiple terminals like that. For example, I can split easily in 4 any layout I want, and I have 4 different terminals. If you want to install Terminator, you can simply type install apt install and Terminator. You have binary packages for Ubuntu, and you can find the documentation on Google. You can easily find the Terminator keyboard shortcuts. What I used here is Ctrl-Shift-O and Ctrl-Shift-E to split the terminal, and you can find the rest of the documentation on the internet. So I will use sometimes the standard terminal, sometimes Terminator. Now to write code, I will use Visual Studio Code as a main IDE. So Visual Studio Code is free to use, and I find it quite convenient to write Python and C++ code for ROS2. I will just show you my extensions. So I have only 3 extensions here to keep it very minimal and simple. The C and C++ from Microsoft, the Python from Microsoft, and also the CMake because we will need to edit some CMake files, so we have the CMake language support when we write the file. And one thing you can do if you are using VS Code is to install sudo apt install python 3 pip, which anyway I think you will need one day or another. You can install that, so it's already installed for me. You can install that because when you start editing some Python file, you will be able to use the auto formatting. And to use the auto formatting, you can press Ctrl, Shift, and I. And the first time you do that, it will ask you to install a PIP package. Actually, it will install it for you, but you will need to have Python 3 PIP. Okay, and lastly, I will use Gedit. So Gedit, when I simply need to edit a very simple text document, well, it's the most basic text editor. You write text, you save, and you close the file. That's it. So that's my main setup. I hope this will help you navigating the course. And just as a conclusion, you use whatever you want. The point here is to learn ROS2 with the tools that you are more familiar with.
So let's install ROS2 Foxy. You can just type install ROS2 Foxy on Google and you will get to that page here. And we're going to choose binary packages for Ubuntu here, Ubuntu 20.04 with Debian packages. So you click on that. And then you can scroll down and you have all the instructions. So I'm going to show you what you need to do from that and also add a few stuff that's going to help us in the following of the course. So first of all, you can just do locale here. You will need to set locale and check that you have UTF-8. If you don't have that, well, here I have it, but I'm still going to do all the other steps. So you just do that one by one. Okay, second step, and then that one. Okay, and then export with UTF-8, and then if you do local again, well, this is what you should get. All right, now we're going to set up the sources. So to set up the sources, we are first going to do this line here. Okay, that's gonna install a few packages. All right, we do this curl command, and then we're going to add the repository to the sources list. Okay, because we need a new repository for ROS2. So press enter for that. And well, we are not going to use this command because you can see it's for Linux Mint. All right, so if you have Linux Mint, maybe you can do this, but here we are on Ubuntu, and so, well, we don't use that one. So after you have set up the sources with the 3 commands here, you're going to do sudo apt update. Okay, and you can see here that when we do update, we have our Ubuntu sources here, but we also have packages.ros.org/ros2/ubuntu. Okay, so we have new sources from which we can now get ROS2 and install ROS2. Okay, so if you see this, that's great. And then, well, we're going to install ROS2 with this command: apt install ROS Foxy desktop. You can see that you also have the ROS base installed with the bare bones, which is foxy-ros-base instead of desktop. So what is the difference between this and this? Well, basically this is the base, like it says, it's the base with just what you need to run ROS and with the minimal setup. So the communication libraries, the message, the command line tools, everything, but you don't have any graphical tools. If you install desktop, you have ROS base plus everything graphical. So for example, RVs, and then you have some demos, some tutorials, and many more packages that we're going to need to use in the course, and also that you are going to need to use later. So that's the one we're going to use. And you can just copy this in the terminal, and here we'll be prepared because you will have a lot of packages. Okay, so you can see it's going to download more than 400 megabytes, and it's going to install more than 2.5 gigabytes, okay, of additional disk space. So that's pretty big. And so you can just put Y for yes, press enter, and then, well, you can wait a few minutes until everything is downloaded and everything is installed. All right, and now everything has been installed. So we have ROS Foxy desktop and all the packages that it contains, which is installed on your machine. Just a quick note here is that you can see that, for example, you have a package like that, a package like that, a package like that, and the similarity with every package is that it's gonna start with ROS-Foxy-something. So if you want to install any other ROS2 package for ROS Foxy, then you are going to write ROS-Foxy- and then name of the package. And so you can install and remove any package like that for ROS2. So that's very simple. And now, well, I'm going to add something that is not here on the installation page. We are going to add a Python module, which is arg-complete, so that when you use later in the course ROS2 command line tools, you will be able to use the auto-compilation. Okay, let's do clear. I'm going first to, so make sure you have PIP3. If you have this PIP3 not found, then you just do sudo apt install python3-pip. Okay, you install that, yes. And then, so let's do clear again. You are going to do pip3 install arg complete, like this. It's going to download it, install it, and well, this is good. So now everything is going to work correctly. And well, that's pretty much it for the installation. So you have more stuff here, but we already need to care about that. And then, well, if you ever want to uninstall ROS2, well, you have the command to do that here. Okay, so you can just uninstall with one command. And now what we can do is do reboot. So it's very important. We have installed many packages, and also the arg complete is not going to work if we don't reboot. So we can do sudo reboot to reboot the machine, and make sure that you watch the next lesson so we can set up the environment for ROS2.
Okay, now ROS2 is installed, but to actually use it, you will need to source one setup script from the global ROS2 installation folder. So what am I talking about here? If you go to /opt/ROS, okay, this is where you will have all your ROS and ROS2 distributions installed. You go to Foxy, which is what we just installed now, and here you have setup.bash. You need to source that script here. And once you have sourced that script, you can use ROS2 in this terminal, in this session. If you don't source that script, you will not be able to use ROS2, and you will get an error, okay? So if I open a new terminal, I will still need to, let's say I'm here, I will still need to source /opt/ROS foxy setup.bash. I will need to source that script in order to use ROS2 every time you open a new terminal. So one thing we can do, because it's quite annoying to always source the script when we open a terminal, is to add that to our bash rc, which is right here in our home directory. So you can use gedit to open the bash rc, and at the end of the bash rc, right at the end, okay, you can add a new line, and that line will be source setup.bash. Okay, you can save the bash rc, close it, and when you open a new terminal, whether it's a new window or anything, so you open a new session, your bash rc will be sourced, and it will also source the setup.bash script from the global ROS2 installation folder. So this step is actually very, very important. If you don't do that, you won't be able to use ROS2. After all this installation process, let's simply launch your first ROS2 program. For that, we won't write any code, we will just use existing examples that were downloaded during the installation. So just type what I type, and it's just a preview of what we will do next. It's okay if you don't understand everything, the point is just to get something working quick. So you can type ROS2 and space, and then press tab twice. Okay. First of all, if you don't get that, it means that the ROS2 installation may not be complete, or you may not have sourced the environment and put that in your bash rc. So if you don't get that, make sure you followed the previous lecture and made every step. Now, let's run our program. So we will do ROS2 run. We will select demo nodes cpp and talker. So we are launching the talker program from the demo node cpp package. And as you can see, we have a log. Talker is publishing hello world with a counter. And now in another terminal, which is also sourced because the bash rc was executed with that line, we can use ROS to run demo node cpp and the listener. And the listener, so this program and this program are linked, of course, and the listener will listen to the talker and just print what he gets. So you can see here, we just print the messages that were published by this program here. If I kill, so you can kill a program by using Ctrl+C, okay? And as you can see here, no new message. If I start it again, we have the messages from the talker. Great, so you have launched your first ROS2 program. And the point of this lecture is that you can check if your ROS2 installation is correctly working. If you have that, it means yes, it's working. And now you will be able to go to the following and actually write your own ROS2 programs. Alright, ROS2 is now installed and configured for your environment. Now in the next few lessons, you will write and run your own ROS2 programs or nodes. I will explain what is a ROS2 node, and then you will directly create one. To set up a new node, you will first create a ROS2 workspace in your home directory. Then you will create a package inside this workspace, and you will write the node inside the package, set the node up, compile it, and run it. As you can see, lectures are duplicated for Python and C++. I start with Python, then do the same thing with C++, so you can learn with both languages and see the similarities and differences between a Python ROS2 program and a C++ ROS2 program. Even if you want to learn ROS2 with only one language, I really encourage you to at least watch the lectures for the other language. And at the end of this section on nodes, you will be able to download the complete workspace with all the code for both languages. Now go to the next lesson to create your ROS2 workspace. To create your own ROS2 programs, you will need a build tool specific to ROS2. So this build tool is called Colcon and was specifically created for ROS2. So let's install it. Now, you can install with sudo apt install python 3 colcon common extensions. Okay, so you install that. Great, so Colcon is now installed and you can use it. I will not go into too much details right now, but you will just see how to use it very soon, and along this course I will explain it a little bit more. And actually there is one more thing we need to set up with Colcon, which is the auto-completion feature, which is not enabled by default, so we will need to do that. You can go to, okay, follow me there, user, share, Colcon complete, and hook. Okay, here you have a bash script, Colcon complete bash, and you will need to source that script in this terminal in order to use the complete for Colcon in this terminal. So again, you can do that every time you need to use complete with Colcon, or you can also just go to your bash rc and add this line. Okay, right, let's add it right here. So what are we going to do? Source, and then I'm going to copy the path here, and then I'm going to copy the script, add a slash, okay, and save the bash rc. So this first line, very important. If you don't do that, you won't be able to use ROS2 at all. This line is less important. It's just when you use Colcon to build your packages, which we'll see later, it will allow you to use the auto-completion features. In this lecture, you will see how to create and set up a ROS2 workspace. This workspace will be the place where you write all your code for a ROS2 application, and that's also where you will compile this code. So let's create a workspace. First, let's go to the home directory, and I will create a folder named ROS2_WS for workspace. You can name this workspace, this folder as you want. This is just a convention that you will often see in the ROS2 community, which is to name your workspace ROS2WS. Inside this folder, we are going to create a src folder, which is a source folder. Okay, so we have that, which is our workspace. And all the code and packages that we are going to create in the following will be in the source folder of that workspace. So now if you go to the ROS2 workspace directory, you can do colcon build to actually build your workspace. And we've just installed Colcon before, so if you get an error here, make sure you've watched the previous videos. And as you can see, we have a successful build, and of course we have 0 package because we didn't put anything in the source directory. If I check what's inside now, as you can see, we have 3 more folders. A log, which contains log of the build process, and then a build folder and install folder. If you go to this install folder here, again, we have a setup.bash script. We also have a local setup.bash script. Okay, so guess what we will have to do? Well, we will have to source that script or that one. So here, for example, I'm going to source the local setup.bash, and which means that now I can use whatever I've created in this workspace. So we have local setup and setup. What is the difference? Well, very basically, local setup.bash will simply source that workspace, which we can call an overlay, and that's it. And setup.bash will source this workspace here, plus the underlay workspace, which is the global ROS2 installation. Well, that is quite a nuance that you don't really need right now to start with ROS2. So basically, in this course, I will use the setup.bash script. It just brings less confusion. So again, if I open a new terminal, what do I need to do? I need to source this setup.bash script if I want to use the functionalities from the workspace, which means the functionalities I've written. So we're going to the bash rc again, which is in the home repository. And we already have source opt ROS foxy setup.bash plus the call cone are complete, but we don't care about that right now. And you're going to source ROS2 workspace install setup.bash. Okay, so again, I'm using the setup instead of the local setup just to make things simpler. Save that file. And now when I open a new terminal, that script will be sourced and that script will be sourced. So I can be sure I can use the ROS2 functionalities, and I can be sure I can use my own functionalities that I've added in the workspace. To create a ROS2 node, you need a package first. Packages will allow you to separate your code into reusable blocks. Each package is an independent unit. For example, you can have one package that will handle a camera, another package for the wheels of your robot, and yet another package that will handle motion planning for the robot in the environment. So let's create a Python package in your new ROS2 workspace. So first you will navigate to the source directory of your workspace. This is for now empty. And to create a package, you simply type ROS2 pkg create. So that is the command to create a new package. Now you need to give a name. We will call it my pkg. So my Python package. So that's simply a name, so we can use it during the course for all the Python tutorials. And now you need to add an argument to specify which kind of package you want, because in ROS2 there is a difference between a Python package and a C++ package. So you will use the build type argument with amount Python. Amount is the build system, and amount Python means you want a Python package. You can also add some dependencies. So dependencies are simply packages this new package relies on. And as we will write some code using ROS2, we will need the ROS2 Python library, which is called RCLPy. So RCLPy, you will basically use it in any of your ROS2 Python programs. You can now press Enter. And as you can see, many folders and files were created. We now have a new folder, my Python package. So let's see what we got in that folder. I have opened the source directory of the ROS2 workspace on Visual Studio Code, and as you can see, we have different folders and files. The first folder has the same name of your package and will always have, okay? And in that folder, you will put all your Python nodes. It already contains an init.py file. You don't need to touch that actually, and you will add your nodes here. Then you have a resource folder. We don't need that for now. A test folder already containing 3 test files. You will be able to put your tests on that folder. And then we will check the package.xml. So each ROS2 package, either a C++ or a Python package, will contain a package.xml file. In that file, you have basically two things. The first is a bunch of information here. So the name, the version of your package, a small description, and then a list of maintainers, followed by license. As you can see, this is empty for now. If you ever want to release your package or share with the open source community or even add a commercial license, then you will need to edit those tags. But for now, we don't need to do that. Then we have the dependencies. So the dependencies, as you can see, we have the RCLPy that we specified when we created the package. So if you need to add a new dependency, you will add another depend tag below that one. And here you can see the amount Python build type for the package. Finally, we have two setup.cfg and .py files. We will see that when we actually create a ROS2 node. That will be useful to install the node in your environment. So your package is now ready. With just one line, you have set up everything. And if you want to compile your package, you will simply go to the ROS2 workspace, so in your workspace, and you will do callcon build. Okay, and your package is now successfully built. And if you want, you can also, it's what we will use in this course, use callcon build followed by packages select. And as you can see, I press tab and the auto completion works. If it doesn't work, please check out the previous lecture where I show you how to enable the auto-completion for Colcon. So package is select followed by the name of your package, my Python package. As you can see, the result is exactly the same because we only have one package for now, but if you have many packages, this will allow you to just compile one package. If you want to make only a few tests in one package, you can compile only that package and the development time will be much shorter. Alright, your Python package is now ready to host any Python node. In this lecture, you will see how to create a ROS2 C++ package. Please make sure you've watched the previous lecture on how to create a Python package so you will better understand. So we will go to our workspace again in the source folder, and here we already have one package, the MyPython package. We will create a new package with ROS2 pkg create, and let's name this package mycpp package. So that's where we will put all our C++ code for this course. Now you will also specify build type, and instead of amount Python, you will use amount cmake. So that will create a C++ package. We will also add a dependency, RCL CPP. So you have RCL Py for Python and RCL CPP for C++, which will allow you to use all the ROS2 functionalities in your C++ code. So you can press enter and you can see we have a new package. Let's see what we have in that package. So first of all, you can see that the architecture of the C++ package is quite different from the architecture of the Python package, and that's just because we changed the build type here. So that's very important, okay? Now in that C++ package, we have an include and a source directory. So it's quite common in C++, you put your header files in a include directory and your CPP files in a source folder. And now you have the package.xml, which is basically the same thing as for the Python package. We have the informations first, then we have the RCL-CPP library. If you need other dependencies, you will simply add another depend tag below that one, and you have the amount cmake flag that we used to create the C++ package. And also you have a cmakelist.txt, and when we use C++, we will need, of course, to compile our code. So that is where you will do that. That is where you will also say where you want to install the code, etc. And as you can see, we also have here the dependency for RCL-CPP. So if you need to add a new dependency for your C++ package, you will need to add it here in the package.xml and also in the cmakelist.txt. And we will talk about this file more along this course. So now if you want to compile this package again, you will go inside the ROS2 workspace directory and use colcon build. So that may be quite long for the first time. And you can see we have my C++ package and my Python package that were built. Now, if I do that, colcon build, packages select, and I only write my CPP package, it will only build my CPP package. So you can see how the packages select argument works here, and that will be quite useful when you develop. So your C++ package is now ready. Now let's see what is a node, so you can write your first node inside your first packages. What is a ROS2 node? A node is a subpart of your application and should have a single purpose. Your application will contain many nodes, which will be put into packages. Nodes will then communicate with each other. But let's just see with a real-life example. I will show you a very simplified example so you can easily understand what is a node and why is it useful. Let's go back to the previous slide where I explained to you what packages were. So a package is an independent unit inside your application. Now, a package which is empty will not do anything. So we will create nodes inside the packages. We start with the camera package. This package will handle a camera as an independent unit. So what should we put inside? First, we need a driver for the camera to be able to program it and get frames from it. We also need a program that will take those frames and do some image processing work. We could also add any other program related to the camera we are using. All those programs in blue are nodes. Each node can be launched separately. So first you will launch the driver and then the image processing node. Now the nodes will communicate using ROS2 communication functionalities, which we'll see later in this course. Alright, we have our camera package filled with all the nodes we need. Note that sometimes it can be quite hard to know if you should put two nodes in the same package or not. For example, the image processing node could be part of another package which only handles image processing for any camera. We could add many other processing nodes, and this new package will communicate with any other camera package, which include drivers. But for this example, let's just say that the image processing is specific to the camera we're talking about, and both driver and image processing nodes are using some common dependencies. We have another two packages in our application. Let's check the motion planning package. So in this package, you can expect to have a motion planning node, which will compute motion planning for your robot. We can also add a path correction node, which role is to modify the motion planning due to external factors. So great, we have two packages filled with nodes. What we can do now is to make two nodes inside different packages communicate together. We link the image processing node to the path correction node. The image processing node will analyze frames coming from the camera and will send an analysis of the environment to the path correction node. This node will then be able to notify the motion planning node. And we finish with our third package, which is the hardware control. This package, as an independent unit, will control the hardware of the robot. That can be wheels, a robotic arm joint, or anything else. In this package, we'll find some drivers to control the motors. The drivers are controlled from the main control loop node, and finally, let's say that the position data, which is coming back from the motor encoders, is sent back to the control loop for precise control and is also published by a state publisher node. We have three nodes in this package, and now the motion planning node from the motion planning package will send computed trajectories to the main control loop node inside the hardware control package. To complete the architecture, the hardware status of the robot is published, and both the motion planning and path correction nodes are getting those messages. Well, that is maybe quite complicated for you to get everything right now, but I think you have a better idea of what is a node and why it is useful. Feel free to come back to this lecture after you make some progress on this course. You will understand more things. So, you've seen with a real-life example how nodes are used. Now let's go back to the node definition. A node is a subprogram of your application which is responsible for one thing. Just as when you write a class with object-oriented programming, you know that a class only serves a single purpose. If you have two different functionalities to implement, then you have two different classes. Well, that's similar for nodes. Nodes are combined into a graph and communicate between each other using ROS topics, services, and parameters. We will cover the communication tools in the next sections. So, what are the characteristics and benefits of nodes? First of all, they reduce code complexity. If you correctly separate your application into packages and nodes, then it will be much easier for you to scale your application. Trust me, if you write everything in one block, then after some time, you'll spend more time fixing your code than actually developing new functionalities. Nodes also provide a great fault tolerance. If you run your nodes in different processes, then they are not directly linked, and they can still continue to communicate thanks to ROS2 communications. So, if one node crashes, it will not make the other nodes crash. First, that's great for debugging. And second, that's great if you have, let's say, a critical node running your hardware that is well tested, and you just add another new node in your program. Even if this later node can crash, it will not affect the critical hardware node. ROS2 is language agnostic. It means that you can write one node in Python, another node in C++, and both nodes can communicate without any problem. Python and C++ are the two most common languages for ROS2. Through some other libraries, you can also use other languages to create other nodes. This characteristic is really great. For example, you could choose to develop your entire application in Python, while some nodes will be written in C++ because they need fast execution speed. Note that two nodes can't have the same name, so in your programs and in your code you will have to make sure that all nodes' names are unique. Alright, so in the following, we'll see how to actually create nodes in both Python and C++, how to use them with command line tools, and then how to make them communicate between each other. Now that you know what is a node, let's create a Python node in your new Python package. So first, you will write the node, and then you will see how you can install it and run it, and then you will see how you can improve the node with object-oriented programming, and you will get a complete template you can use for all your Python node. So let's go into the ROS2 workspace that you already created. In the source folder, you have the MyPython package. And in this package, we have a folder which has the same name as the package. We will go inside this folder, and here we will create our file to write the node. So for example, let's name this file myFirstNode.python. You can now edit the file, so let's find it here. And first we will add the interpreter line for Python 3. Okay, so ROS2 only works with Python 3, no Python 2 anymore. And we will create a structure for the main. Okay, we will create a main function here, and we will put optional arguments. Okay, so that is a very basic Python structure, and now we want to use the ROS2 functionalities. So to use ROS2 functionalities, we will import RCLPy. RCLPy, if you remember, we added the dependency to RCLPy, and you can find it here in package.xml. This is the ROS2 library for Python. So the first thing we will do in our program is to initialize ROS2 communication with rclpy.init, and we will pass the arguments from the main. So args equals args. Okay, so the arguments from the main function will go to the arguments named args in the rclpy.init. This line is the first line you need to write in every ROS2 program. It basically starts the ROS2 communication, and if you try to use any of the ROS2 feature without that line, it will of course fail. So then you will write your code, and at the end you will write rclpy.shutdown. That will be the last line of your program. So basically you first initialize ROS2 communication, you do your program, and then you shut down the communication. We will now add a node inside the main, so we will create a node, and to do that we will import the node class. From rclpy.node import the node class, and we will simply use the node constructor here with the node name as a parameter. So let's call it Python test, like that. That is the name for the node. Note that it's best practice not to, for example, you could say Python test node, but for the name of the node, it's better not to use node because it would be redundant. So your node will be created, and then immediately after that, the ROS2 communication will be shut down and the program will exit. When the program exits, your node goes out of scope and it is destroyed with everything that you've created inside this node. So you don't need to do it manually. And because this program will not do anything, let's actually print something with get logger. So you will use the get logger function from the node object, and then you have info, for example, and let's say hello ROS2. So that is your hello world in ROS2. So to recap, you first initialize ROS2 communications, then you create your node, you give it a name, you then print something, and you shut down the ROS2 communication. The node is not the executable, the node is not the file, the node is created inside the file, okay? That is important. And the name of the node is not the name of the file. So now let's try to run this node. The most basic way to run this file is simply to run the Python script. So we will mark it as executable and simply launch it. As you can see, we have the hello ROS2. It's working. You have the info level flag for the log functionality, the timestamp, and the name of the node followed by the actual log. You will have that for every log you do with ROS2. And we will come back to our program and add one more thing here, rclpy.spin, and we pass the node to the function. That function is very important and you will use it in almost all your programs. So what does it do? Spin will basically put the program here, will pause the program, and will allow your node to continue to be alive. So for now, the node has no real functionality, but later on, when you start to add some publishers, subscribers, services, etc., then you will have code to execute and you will have callbacks, and those callbacks will be able to be called from the spin function. So let's see what it does. As you can see, we still have the hello ROS2 line, and now the program is still running. Okay, nothing is happening because we didn't ask it to do anything, but the program is still here. And if you press Ctrl+C, then the program exits. And don't worry about the log here. When you press Ctrl+C, it doesn't really matter. So when you press Ctrl+C, the spin will stop. So the node will stop spinning, and then the program will resume, and you have the shutdown of the ROS2 communications. I will often come back to this spin function, and you will understand it after some practice. So that is the most minimal node you can write. Now we will see how to install this node. So with Python, of course, you don't need to compile the file to execute it. You just mark it as executable and you can just run it like that. But with ROS2, we will install the file into your workspace. Because if you always want to run your node from the terminal directly like that, it's not that scalable, and you will be able to have much more functionalities if you install the file, and we will see the benefits a little bit later. So let's see how to install this file. We will install it from the setup.py here. So you have setup.cfg, which will tell where you will install the file, and here you will say in this array console script the files and the nodes to actually install. So if you take a look at this setup.py file, you have, for example, version, maintainer, description, license, and that is quite similar to what you had in the package.xml here. So if you ever need to release this package, you will need to edit that and also the lines here. So those will be identical to those in the package.xml. So to install the node, we will add a new line here, and we will need to specify a name for the executable. So what will ROS2 do when we install the file? It will take this file here, it will copy it and make some modifications so it becomes an executable for ROS2, and that executable will be installed in the install folder of your ROS2 workspace. So we need to specify a name for the executable, and let's use something different here, node. So we use Python node for the executable. Okay, then you will need to put equal the name of the package, my Python package, dot name of the file, my first node, and then 2 and the name of the function you want to start. So we will start from the main function right here. That's why we created this main function instead of putting all the code right here. So that should be okay. We will go to our ROS2 workspace and colcon build. We can use packages select, so we only build the my Python package. And let's see where this node has been installed. So we will go inside the install folder. Okay, you have the my Python package, and inside that you have lib. So why lib? Because here you have lib. Okay, that's from the setup.cfg. You go to lib, and inside lib you will go to my Python package, and here it is. So you can run it, and it works. Then you press Ctrl+C to kill the node. So you already have two ways to start your ROS2 node, either directly from the file that you created or from the file that you installed. And note here, the name of the file is py node, just as we requested here. It's not the name of the file you wrote. Okay, that's very different. And we will not use either of those two options when we actually start ROS2 node. We will use a ROS2 command line tool named ROS2 run. So after you've compiled your package and installed the node, go in another terminal, and it's better to source first your bash RC, because this will source your ROS2 workspace for this environment. And when, for example, you create a new package or you create a new node, it's always better to source your environment through the bash RC, so you are sure you have the latest version and you don't get any error when you try to access some node or other stuff. And we will simply type ROS2 run, then followed by the name of the package, my py package, followed by the name of the executable. You start it and it should work. Yes, the node has been started just as before, and you can kill the node. So in the next section we will see more about this command and the other ROS2 command line tools. And to recap quickly, so you have created a Python file here, and inside this file you have created a node. Okay, so the node will be created when you actually write this line, when you call the node constructor. And one important thing to be sure to understand is that here you have the name of the file, which can be different from the name of the node, which can be different from the name of the executable. Okay, that's often a common misunderstanding when you start with ROS2. And now that you can create and run and install your first Python node, let's see how we can improve this structure here with object-oriented programming, because that is the recommended way to write your node with ROS2, and it will make your life much easier in the future. Let's now improve this node over there with object-oriented programming. It will make your node much more scalable, and it's also the recommended way to write node in ROS2 directly from the ROS development team. So first we will create a class. Let's call it myNode. So the class should of course be named after what you want to do. If this is a camera driver, then you will call this camera driver node, okay? And we will make this class inherit from node, from the node object. So that is the way to create a node. You create a class inheriting from node object. Then we will write the constructor of the class, and we will directly call the super function init. So that will call the init function from the node, and we will give here the name of the node. And then we can also use this line. So instead of node get logger, we will actually use self, because self for this object, which is a node, so we can directly call the logger from self. And here we will remove that. Instead of creating a node object, we will create a myNode object. And well, that's it. This node is exactly the same as before, but using object-oriented programming. Let's run the node. So we will compile again. Let's find the call build line. Okay, and if we run node, everything is the same because we didn't change anything. And that will be your template for writing ROS2 Python node. I will give you the template later on this section, so you can directly kind of copy and paste that. Every time you want to create a new node, you will need to change, of course, the node name here and the node name here. And if you want, you can put a log on it. And now let's actually, because this node still does nothing apart from printing a log, let's use one of the most basic and common functionality in ROS, which is a timer. A timer will allow you to call a function with a given rate. For example, you want to call a function at 10 Hz, then you use a timer. So let's do that. We will do that directly inside the class that we've created here. And before we create the timer, we need a callback function. So let's call it timer callback. Okay, and in this function we will self get logger info, and let's say hello again. Okay, so we have a function that says hello, and then in the init function, we will do self create timer. So this is a function from the node object that we can directly get with self. The first argument is the period between two callbacks. So let's say we want to print at 2 Hz. So 2 Hz is 0.5 seconds, so one time every 0.5 seconds. And then we need to give a function to call, and we will give the function timer callback, self timer callback, because the function is defined inside the node. And now let's run this. So again, we can build it. So it will be installed, and we can run it here. Okay, we have hello printed every 0.5 second. Great. You can press Ctrl+C to kill the node. And let's improve a little bit our node. We can, for example, add a counter, self counter 0, and let's say that we increase the counter by 1 every time the callback is called, and we will simply print hello plus the counter value. Okay, so what this code will do is initialize a variable here to 0, then we print a log, we create a timer with a 0.5 second between each callback, and then we give a callback function, which is this function, and in that function we increase the counter every time, and we print hello counter. Okay, so everything here will be executed when you write this line here, when you call the myNode constructor. Okay, and then the RCLPy spin will make the node spin. So the timer will continue to run while the spin is still running. The timer will run, and you will see that line printed until you press Ctrl+C, and when you press Ctrl+C, the spin will exit. And your node won't be spinning anymore, and thus will not be able to do any kind of callback, like timer, subscriber, everything else. So let's run this again. And as you can see, if you have an error, a syntax error in your Python file, then you will get the error when you build the package and when you try to install the executable. So it will not only create an executable, it will also check that the syntax is correct. So now that the syntax is correct, it should work. Okay, and we can now execute the node and hello 1, 2, 3, etc. So as you can see, we can easily create a complete functionality with just a few lines of code. And now that you can write your code inside your custom node class, this main function here will always be the same. You initialize ROS2 communication, you create your node, you make your node spin, and when you press Ctrl+C, this exits, and you shut down ROS2 communications.